Hi guys, I hope you all are doing well. So today we'll be starting with the chapter 5 of class 10th mathematics, that is arithmetic progressions. In the last chapter, we learned quadratic equations. How do we represent quadratic equations? How do we solve them, etc. So I hope you all have gone through the chapter and practiced it well. So today we'll be starting with the chapter arithmetic progressions. So in day-to-day life, you have noticed some patterns, maybe in terms of salary. If I say if I have joined a company for some salary, let's say 1,000 rupees per month. Okay, and I'll say that for first year my salary would be 1,000 per month, and then for the second year it would be 2,000 per month, and and for the third year it would be 3,000 per month, and so on up till 10th up till 10th year. Okay, so can we notice? What we notice is as for first year my salary was 1,000. For second year it was 2,000. For third year it was 3,000, and up 10th year it will be, you can say that it will be 10,000, right? 10K. So we can say that there is a pattern, there is some sort of connection between the previous number and the next number. So these types of pattern can be noticed in our day-to-day life, as you can see in the textbook also. Here we have an example of Rina, who just had who just had got a job, and her starting monthly salary is 8,000 with an annual increment of 500 in her salary. So for the first year, it would be 5,000, 8,000. For the second year, it would be 8,500. And for the third year, it would be 9,000, and so on. As long as she works with the concerned company, right? So yes. Then second example, we have the lengths of the rungs of ladder uniformly by 2 centimeter from top to bottom. You can see that this ladder, it is in this shape. So basically, it decreases, right? So these are some patterns that can be noticed in our day-to-day life, right? So all these patterns, we can say that they form a progression. Basically, if we say, like you can see here, we have a number of list: one, two, three, four. So you can say that the numbers are progressing. The numbers are progressing. Basically, it was one, then it went to two, three, and progression can be in any terms. It could be the decrease of numbers also, and the increase of numbers also. That doesn't that varies. Okay. So we can say that this is into a arithmetic progression, or a progression. We can say as a series also. There are many numbers such as in our lives. Okay. Okay, so in this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms. We shall also see how find their nth terms and sum of n consecutive numbers. Use this knowledge and use this knowledge in solving some daily life problems, right? Okay. So, in this chapter, we are concerned with the terms that would only increase, not decrease, by adding a fixed number. Okay. So, for example, in this example, we have just a second. Hmm. So, in this example, let's say, take a example of even numbers. Okay. Now, if we take even numbers, let's say I have 2, 4, 6, 8. 10. So I just want even numbers between 0 to 10. Okay. So I'll have these many numbers. Okay, cool. Now you can notice one thing. Okay. So yeah. So you can notice that this is our first term. Basically, all of these numbers are called as terms. This. So this is a term, this is a term. Okay. You can also see it in the textbook that each of the numbers in the list is called a term. Okay. So you can notice one thing that when I add 2 to the first term, so basically if I add plus 2, I get 4, right? Similarly, if I add plus 2 to 4, then I get 6. If I add 2 to 6, then I'll get 8. And if I add 2 to 8, then I'll get 1, right? So, when we add to all of these numbers individually, then we get the further numbers. So basically, if we as you can see that plus 2 is a common number, right? So it is a constant. We are only adding 2, right? So basically, arithmetic progressions are is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, first term is an exception. We will not add any we do not have a preceding term for the first term, right? But as soon as we add a common as we add a common number to the first term, we get the second term. Then when we add the same common term to the second number, we get the third term. So you can see that the difference between these two numbers is 2 only. 2, 2, 2, right? So this is these types of lists are called as arithmetic progressions. Okay. Oh, okay. So we saw that the this is our first term. So 2 is our first term. 10 is our last term because that is where our list ends. Okay. Okay. Right. And you can notice that the 2 that we have written, 2 is the common difference. So basically, the number that we add to the preceding term to get the next term is called as common difference, and it is denoted by D. Common difference could be negative, could be positive, or it could be zero also. That will not so that doesn't matter. It can be positive, negative, or zero. Okay. Now, if we can say that, let's say we have a list. Okay, we have a list A1, A2, A3, A4, A5. That's it. Okay. Now we know that the common difference is same. For all the terms, common difference is same. And what is the common number? That is the next term minus the preceding term. So basically, here we can say that now here we don't have for this number, we don't have a previous number. So we need to start with A2. So here A2 minus A1 is the common difference, right? That can be equated with A3 minus A2 is equal to A4 minus A3 equal to A5 minus A4. A4. That shows us ki, the common difference is constant and it does not change. And the common difference is the difference between the next term and the preceding term, or the term and its preceding term. Okay. So this is known as common difference. So we can write it as D. And if we have any two of the numbers from the list now, we can calculate the common difference. If we have two consecutive terms from the list, we can calculate the common difference easily. We just need to have A2, A1 or A3, A2 or A4, A3 or A5, A4. Any of them works. Okay, cool. Okay, so now we have seen that what is an AP, what is the common difference, what is the first term. First term is denoted by, I'll just write the notations. We have first term is denoted by A. Then we have common difference. Common difference is denoted by D. And then we have last term, that is L or AM also. and we have nth term that is denoted by an. So basically, if we put 1 in this, so basically we get first term, right? So first term is a1 or similarly like that. So first term a1, a2 up to an. I hope that is understood. There are many examples of AP, such as the heights of heights of some students of a school standing in a queue in the morning assembly are 147, 148, 149, 157. May know that in schools they make you stand height wise, right? So the shortest person is in the front and the tallest person is in the last. So the height of the students increases gradually, right? So that can be taken as an example. Okay. Next is we need to see the general form of the AP. So how do we represent a AP generally? Okay. Now we know that the first term is A. Aila. Now we know that the first term is A. Okay. Now if we add what was the condition for AP, we get the next term by adding the common difference to the previous term. Okay. So if we add previous term, we'll get the next term. Okay, cool. Now next up we need to again add the common difference. So basically we need to add common difference. So we'll add d to a plus d. So we get a plus 2d. Similarly, we get a plus 3d and so on. So the coefficient of d increases linearly from 0 because here there was no common difference 0, then 1, then 2, then 3, and then henceforth. So therefore, this is the general form of the AP, that is arithmetic progression. So I think you have got the meaning of arithmetic progression, right? So this is the general form of AP and this is how we represent the AP. Now there are two types of AP. Now there are two types of AP. First type is finite and second is infinite. So basically finite and infinite the term itself says that what does finite and infinite mean. Basically when we have certain numbers like maybe a1 a2 till an, so therefore an is the last number, right? Last term, maybe we can say it as. But for infinite we don't have a last number because it can go up till infinity. So A2 and it can go till anywhere. So we don't have a last number over here, last term over here. No last term present. Okay, that is the only difference between finite and infinite. Maybe the solving techniques differ over here, but the solving techniques differs slightly, but that is not a problem. So this is mean finite and infinite AP. I hope the recording is on. Yeah, it is. Okay. So, next up, we have infinite arithmetic progressions. Right. Cool. Huh. We have the formula for common difference that is just for the sake of writing, we can say it as D is equal to AK plus 1 minus AK. Okay, so here AK is K plus 1 at the term, and here AK is kth term of the AP. So this is the common difference. You can put any of the values of for K and you will get the common difference of the AP. I'm so sorry for the disturbance. Okay. So next up we have some examples. We'll just quickly see one or two of them and then we can proceed further. Then we can proceed. Proceed. Okay. Okay. Now for here we have an AP that is 3 by 2, 1 by 2, minus 1 by 2 and minus 3 by 2 and so on. Okay. Write the first term and the common difference. Okay. Ignore this part that the firstly it was positive and then it is going in to the negative side. That does not make any difference. We just need to focus on the core concept of AP. What we need to write is the first term and the common difference. We know that the AP that the first term of the AP is the first term. ठीक है, the number starting with the AP is first term. ठीक है. Now you have understood that what is the first term. ठीक है. Cool. But okay. Now for the second for the common difference, we can use any of the four terms that are given to us. We can either write the common difference as 1 minus 2 minus 3 by 2, or minus 1 by 2 minus 1 by 2, or minus 3 by 2 minus 1 by 2. They all of these calculations will give us the same answer. If we write it minus 1 1 minus 1 by 2 minus 1 by 2, that gives us minus 1. Yeah, so minus 1 is the common difference. So we can solve the AP further also. If we just add minus 1 to minus 3 by 2, then we'll get the fifth term for the AP and so on and so forth. Okay. Yes, okay. Now, example 2 is which of the following list of numbers form an AP, and if they form any AP, write the next two terms. Okay. To to check whether the given series or list of numbers form an AP, we need to check the common difference for all the terms. If the common difference is constant, then yes, they form an AP. If it is not, then obviously it does not form an AP. Okay. For this, for part 1, we'll check the common difference. 10 minus 4, 6, 16 minus 4, 16 minus 10, 6, and 22 minus 6, 6. Right, the common difference is constant. So yes, this is an AP. For to get the next two terms, what we'll do, we'll just add the common difference to this term. So if I add 22 plus 6, I'll get 28. And if I add 28, 6 to 28, then I'll get 34. So yeah, so we have got the next two terms of the AP. Similarly, you can find all the common difference in the first term for all of the other examples. Next up, we have exercise 5.1 that you can do it on your own. If you have any doubts, you can put it in the comment section. I'll definitely clarify them. Okay. Next up, we have nth term of an AP. Now, let us take an example. Maybe I have an progression of even numbers. Okay. Even numbers 2, 4, 6, 8, 10, and I want it till 20th term. Okay, so I want a total of 20 terms in this AP. I want a total of 20 terms in this AP. So maybe it is a very tedious process to go on till 20 terms, because right now we have just written five terms: 2, 4, 8, 10, 8, 10. Then this is the sixth term, seventh term, eighth term, ninth term. That is a very tedious process to do. Instead, we can directly find the last term of the AP. We can directly find the nth term of AP. Now, maybe I can say that I have an AP of even numbers from 2 to 100. So there are many numbers in this, right? And if I just ask you, tell me the 20th number, 20th term, 20th term. So it is a very tedious and lengthy process to go on adding the common difference, and you write 4, 6, 8, 10. Then you'll count that, okay, this is the first term, second term, third term, fourth term, fifth term. That is a very long process to do. So rather we have a formula for nth term of an AP that is written as, I'll not go into the derivation. You can see the derivation in the textbook. That is pretty simple. You can directly uh, you can directly get it through your through the textbook. That is not a problem. So nth term of an AP is given as an is equal to a plus n minus 1 t. I hope that's clear. So basically nth term if I want, I can write it as the first term plus n minus 1 times the common difference. Okay. Now again, let us just come back to our example. That was the AP of even numbers 2, 4 till 100. Okay. Now we know that this is an AP of a common of an even number. So from the AP we can draw two conclusions. That is, A is equal to 2, and the common difference is also is equal to 2. What we need to find is we need to find the 20th term. So basically, if we want to find the 20th term, therefore in this case our n will be 20. So what if I just put 20 in the place of this formula? So basically A20, because an is equal to a plus n minus 1 d, or let's just say an. So therefore, substituting all the values from the AP, A20 is equal to A. A was 2 plus n minus 1. So 20 minus 1, and the common difference was 2. So A20 is equal to 2 plus 20 minus 1, 19, 19 into 2, 38. And therefore A20 is equal to 40. So therefore, the value of the term, or the term in the at the 20th place, or the 20th term of the EP is 40. So therefore maybe 2, 4, 6, somewhere here it would be 40, and somewhere here it would be 100. So this is the 20th term of the AP. So therefore, you can find out the nth term of any AP. Sometimes in the question, it could be given that you are given the you are given the nth term. You will be given the nth term. You will be given the common difference, and then you need to find the first term of the AP. No need to worry. You can just substitute all the given data in this formula, and whatever the missing data is, you can get it from there. So I hope that's clear, and therefore we can move further. Cool. Yeah. Okay, it could also be also some question would be given to you that find the number of you will be given the last term of the AP, and you will be given that find the number of terms in that AP. So basically you can just put it in the formula. Again, you will get the value of n. N is the number of so you'll get the value of n, and then you can draw the conclusion that okay, these many terms are present in that AP. We can see we can we can just take we can just take an example. Which color do I choose? Orange. Okay. Find the 10th term of an AP 2, 7, 12. So you can see that A is equal to 2, and the common difference is 7 minus 2 is equal to 5, or 12 minus 7 is equal to 5. Substituting the values in this formula, we get 2 plus 10 minus 1 into 5, that is 2 plus 45, that is 47. So 47 is the 10th term of this AP. So somewhere it will be here. Okay. Cool. Now next is, which term of the AP 21, 18, 15 is minus 81? Also, is any term 0? Give reason for your answer. Okay. Now we have this AP. We'll go step by step. Till this, we'll try to solve it till this part. Okay. For this AP, our A is 21, and the common difference we can see that 18 minus 21. Do not go ulta. Okay. 18 minus 21, or 15 minus 18, that is minus 3. So D is minus 3. Use the common difference using the sign conventions only. Okay, you can use the signs because we have learned that it could be positive, it could be negative, or it could be 0 also. So that is not a problem. ठीक है. Now we have nth term is equal to nth term is equal to minus 81. Now just we'll put the for all the given data in this formula, and we'll get that n is equal to minus 35. Okay, so minus 35, we get minus 35. So therefore minus 81 is the 35th term of the AP. So therefore the 35th term of the AP is minus 81. Okay, now we want to know that is any term 0. So before doing that, we just need to understand one thing, that n, so the nth term is no, the nth term, it could be either, it cannot be 0, firstly. Sorry, it cannot be negative. So it cannot be negative. And also it cannot be in the form of decimal or a fraction. Because if I say I have the first term, second term, third term, so I'll use n in the form of whole numbers only. N would be only in the form of whole numbers. It cannot be fraction. I cannot say okay, this is the 1.5th term of the series. It makes no sense. Okay? So n should be positive and n should be a whole number. That is the only case. If in any question we get n some negative value, or if we get n in a fractional value, then we can say that that this term does not exist in that AP. That is a wrong term for that AP. Now we want to know that if there is any zero term, if any term is zero in that AP or not. So an, we'll put an is equal to 0. Similarly, then putting it in the formula of common of n term of AB, we get n is equal to 8. So now we can say that n is positive, okay, and n is a whole number. Done. So therefore, an eighth term of the AP is 0. Okay. I hope that is clear. Now we will take one more example, that is check whether 301 is a term of the list of numbers 5, 11, 17, 13 or not. We'll check. We have this AP, we have this number term. So we need to check that is it does this term exist in the AP or not. So for our AP, our A is 5 and D is equal to 6. Okay. If we put all the things in, let's say 301 is our nth term. So putting it in the formula, 301 is equal to 5 plus and minus 1 into 6. So here we get value of n is equal to 151 by 3. So therefore, we can as this is not a whole number, this is a fractional value. We can say that 301 term does not exist in the given list of number. It is not a term of the given list. Okay? I hope that is clear. One more type of question that you need to solve would be how many two-digit numbers are divisible by 3? How many two-digit numbers are divisible by 3? So basically, two-digit number, okay, and divisible by 3. Now, if the number is divisible by 3, so therefore the common difference would be 3, because 3, 6, 9, all of these numbers are divisible by 3 and the common difference is 3, because obviously to be divisible by 3, their common difference should be 3. But now the catch is we need two-digit numbers. So we need to find the first two-digit number that is divisible by 3. So first two-digit number is 10. 10 is not divisible by 3. 11. 11 is not divisible by 3. 12. Yes, 12 is divisible by 3. So our A would be 12. A is 12. Now we want two-digit number only. So our last two-digit number is 99 and after that we get 100. 100 is a three-digit number. So 99 is 99 a two-digit number? Yes. Is it divisible by 3? 3 33s are 99. So yes, 99 is also divisible by 3. So basically we have got our A, we have got our D, and we have got our last number as well. So what do we need to find is how many two-digit numbers are divisible by 3. So this is the last term. If we find the which term is this, then we'll get the number of terms, the number of two-digit numbers that are divisible by 3. So therefore A is equal to 12, D is equal to 3, and AN is equal to, that is nth term is equal to 99. Substituting this into the nth term formula, we get n is equal to 30. So therefore, 32 digit numbers are divisible by 3. I hope that is understood. 32 digit number divisible by 3. Okay. I think that's enough of the examples. Other rest of the examples you can do it on your own. Next up we have exercise 5.2. Again you can solve it on your own. Okay, last topic for this chapter is the sum of first n terms of an AP. Okay, we need to find the sum of n terms. Okay, let's say we have again have our AP 2, 4, 6, 8, 10. So basically I need to find the sum till the 10th term. So the conventional way would be I'll do 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. I hope 10 numbers are done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I need to find this value. That is a very tedious task to do. Instead, we can use the formula for to find out directly the sum of n terms. So therefore, the formula to find the sum of n terms is given by, it is denoted by Sn, formula for sum of n terms, n by 2 bracket 2a plus n minus 1 d. So this is the direct formula for to find the sum. Now again, let's take our example. In our example, a is equal to 2, d is equal to 2, and our n was 10, right? Because we need to find the 10th term, till 10th term. So if we substitute the values over here, so S10 is equal to n by 2, 10 by 2, 2 into a, that is 2 into 2, plus n was 10, 10 minus 1, 9, 9 into 2. Okay, so we get 5, 2 to the 4, 4 plus 18 is equal to 5, 22, 110 is the answer, right? So sum of 10 terms is 110. So I hope that is clear. This is the first formula for sum of n terms. Now, if we are given with the last term directly, now if I say I have been given with the AP 2, 4, 6, 8, 10. So that is our AP. Now here in this AP, we can say that we are given with the A is equal to 2. We know that D is equal to 2. And we also know that last term or AM is equal to 10. So in this case, we can directly use a formula that is given as S is equal to n by 2 A plus L. So this is a formula that can be used when we are directly given the last term and we need to find the sum of all of these terms. So again, coming back to our example, if we substitute the formulas in it, n our n was fifth term, that was 5 by 2, a was 2 plus L was 10. So that comes as 5 by 2 into 2 plus 10, 12. So if I cut it down, S is equal to 30. You can just cross verify it over here because you can say 4 plus 6, 10, 8 plus 2, 10, and 10. So 10 plus 10 plus 10, that is equal to 30. I hope that is clear. Okay, cool. So again, in the textbook, we are given with the derivation. You can read it on your own and understand it. So this is the formula for sum of the first term n terms of an AP, and this is the formula if we are given with the last term. Okay. I hope that is clear. We'll just quickly see one of the examples. Find the sum of the first 22 terms of AP, A3 minus 2, and so on. Okay. So conventional way would be you will first find all the 22 terms of the AP and then you will add it. It will take much time. It will take much time, and the chances of error would be much higher. Instead, we can do it directly. A is equal to 8, right? D is equal to 3 minus 8, that is minus 5. Putting it in this formula, we need to find 22 terms. So therefore, n is equal to 22. So 22 by 2, 16, 2 8s are because 2 into 8, 2a plus 21 into common difference minus 5, we directly get minus 979 is our answer. I hope that is clear. Next up, we have if the sum of first 14 terms of an EP is 1050 and its first term is 10, find the 20th term. Okay, we can go stepwise. We'll solve it in on our whiteboard. Okay. So we are given that sum of first 14 terms is 1050. So we are given, we'll solve it with our white pen. 14 terms is 1050 and we are given that first term is 10. First term is 10 and we need to find the 20th term. So we need to find A20. Okay. We'll go stepwise. No need to worry. You'll say that we are not given with D. We are not given with D. No problem. We can solve it. Okay. We know that the formula for n terms of an EP is given as S14 is equal to 14 by 2, right? N by 2. 2 into A, we are given with A. Next is n minus 1d. So n minus 1 would be 14 minus 1 into 13 into d. Okay, d is not given, let it be. We can further calculate it. Now we are here, we are given with 1050 is equal to 14 into 2 in bracket 20 uh, plus 13d. Okay, cool. Now if we calculate it, we'll just send 2 over here, then I'll get 105. What is it? 1050, 2100, right? 2100 is equal to 14, 20 plus 13d. Now, if I send this in division over here, 2100 upon 14 is equal to 20 plus 13d. Okay. So, um, if I divide it by 7, I get 7 twos are 7 threes are. So, here I get 300 and 2 ones are 2 150s are. So 150 is equal to 20 plus 13d. Okay. Now if I send 150 back over here to 20, I'll subtract 20. I'll get 13 is equal to 13d, and therefore I'll get d is equal to 10. So therefore I have got d, the value of d. Our answer is not yet finished because we need to find the 20th term, right? Yeah, we need to find the 20th term. So 20th term is given as a plus n minus 1, that is 20 minus 1, 19 into 10. So therefore it is given as 20 plus 190. Therefore 20th term is 200. So therefore this is the answer, and this is how we can solve for the 20th term or whatever it is given. So it may happen that you are not given with some data, you are given with some other data, then you can find the data that is not given, and then you can find an answer for whatever question that is asked. So this is a very simple chapter. You can go through all the exercises. Also, you need to remember one thing, that the sum of first n positive numbers is given by n plus 1, 2. Okay, this is basically derived from the formula of sum of n terms only. You can read it in the textbook. It is given in the solved example. Next up, you have exercise 5.3. Again, that can be done, not a problem. And I think we are done with this chapter. We'll just quickly summarize what we have learned so far. So we have seen that an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. The first number is called the fixed number is called the common difference. The general form is given as a plus d, a plus 2d, a plus 3d, a plus 4d, a plus 5d, and so on. Then a given list of numbers a1, a2, a3 is an AP. If the difference is a2 minus a1, a3 minus a2, a4 minus a3, and so on, give the same value. So if therefore it suggests that D should be common. If it varies, then the given list of numbers is not an AP. Then we have the nth term formula, that is an is equal to a plus n minus 1d. Then we have the sum of first n terms ka formula s n plus n by 2 2a plus n minus 1d. And then we have the last sum of n terms only. If the last term is given, then s n by 2 a plus l is the formula. One more thing that you can remember is if ABC are in AP, let's say ABC are in AP, then B is equal to A by C. This is called the arithmetic mean of A and C. So arithmetic mean of for the three numbers, if we are given of an AP with three numbers, the arithmetic mean of first and third number is the second number basically. So B is equal to A plus C by 2. So that you just need to remember. It may happen that they ask a question on it. Okay. I think we are done with this chapter. Go through the textbook once, read and solve all the solved examples. Solve all the questions from the textbook. That is more than sufficient. And see you in the next video. Thank you so much for watching this video. Bye bye. Take care and have a good day.
वीडियोस बनाने हैं फिल्मोरा है ना।